Hello, today we're going to be doing the What's in That Bottle lab, where we're going to use physical properties of different compounds to try to figure out what type of solid it is by performing a variety of different tests. So I have 6 compounds that we're going to test today. I mean, I know what they are, but in theory, your students would not know what these compounds are before you start. Now, the 5 tests that we're going to be performing are conductivity as a solid, magnetism, solubility in water, conductivity in water, and solubility in hexanes, which is a nonpolar solvent. And the types of compounds present are metallic, ionic, polar covalent, and nonpolar covalent. So we're going to try to use these tests to figure out which one's which. Now you could possibly do melting point as a way to help us figure out the type of solid, but it's not entirely necessary to distinguish between the 6. Okay, so I have the 6 substances and I put each substance in 2 wells. So this is substance 1, so, these 2, substance 2, substance 3, 4, 5, and 6. Now I'm going to run it through a series of tests. The first thing I want to test is it conductive as a solid. So I'm going to use this conductivity tester here. And if both of the lights light up, then we know that it is conducting electricity. So I'm going to go through, I just need to do one of the substances. I don't need to stick it in every single well. We're not seeing anything. Wipe it off in between. Not seeing anything. Oh, I did that one twice. And our last one. So you see, only this last one conducts as a solid. Okay, our next test that we're going to perform is to see whether it's magnetic. I just have a little stir bar that I'm using, but you can use a larger magnet if you have it. And I'm just going to place it over and see if it attracts. Oh, that one attracts really well. Use the other side so it's clean. Okay, so only this third substance was magnetic. Alright, our next test is we're going to test the solubility in water. So in one of the 2 wells, we're going to add just a little bit of water. And for this one, you want to caution students to make sure that there's only a little bit of the substance in each of the wells. Because if you have too much, it might look like it's not soluble when it really is. Sometimes also it might be good to take some substances and put it in under a contrasting background. So I put a little bit of substance 2 here and on the petri dish because it's under the black background, and I'm going to put a little bit of the water on here as well. Okay, so if we get in really close, we can see that this first substance is definitely dissolving. The second substance, which I have here and in the petri dish, is not dissolving. This one is not. This one is not. It's like forming a little clump off to the side. This one looks like it is dissolving, and this big chunk is not dissolving either. Our next test is we're going to see if the substances conduct electricity when they're dissolved in water. So I'm going to go through, now this really only is useful for the substances that do dissolve in water. The ones that don't dissolve definitely aren't going to conduct in water anyway. So I'm going to test the 2 substances that did conduct, or that did dissolve in the water, which is this one. And you see that very faint light? But let's compare that to the last one here. Do you see the really strong light? So this one is definitely conducting to a high level. The first substance here might just be reacting to ions left over in the water from filtration. Alright, our last test is we're going to test the solubility in hexane. Hexane is a non-polar solvent. So again, I'm going to use those wells that we did not put water in. So now if we can get in a little closer, you can see it. This one's a little hard to see because it's white, but it has completely sunk to the bottom and has not dissolved in the hexane. Same thing here. It has not dissolved. It has not dissolved. This one has definitely dissolved. It turned purple even. This one has not dissolved, and this one has not dissolved. So our only one that's soluble in hexane is this one here. Okay, so here are the final results of our testing. Notice compound 1 was soluble in water. Compound 2 didn't show positive results for any of them. Compound 3 was magnetic. Compound 4 was soluble in hexane, turned that purple color. Compound 5 was soluble in water and conducted electricity strongly in water as well. And compound 6 conducted electricity as a solid. So from these results, we can start to figure out the type. So we know that the types of compounds that conduct as a solid are metallic. And we also know that the things that are typically magnetic are also metallic. So why didn't this compound 3 also conduct as a solid? Well, the reason why is because this one was a powdered form, so it was granular, and the atoms were not close enough so that the electrons could transfer between them. So it did not conduct. If you were to solidify that into a single piece, it would have conducted as a solid. Now, the other ones that are soluble in water are ionic or polar covalent. So of these two, number 5 must be ionic because it is soluble in water and it conducts electricity in water. So that one is definitely an ionic compound. This one is soluble in water but does not conduct electricity. So that one we know is polar covalent. From there, we can see that number 4 is soluble in hexane. Since hexane is nonpolar, we know that the compound must be a nonpolar covalent. And then what about number 2? Number 2 didn't show anything here. It's probably not metallic, and it doesn't dissolve in water, so it's or hexanes, so it's probably not a covalent compound either. What we're going to see, and as we look at the compounds here, is this one is probably an ionic compound that does not follow the solubility rules. So an insoluble salt. Now from here, what I usually do with my students is I reveal the 6 compounds that we were testing and have them match the formula for the compound with the particular type. Usually people will pick out first that iron is a magnetic one. So we know that iron is number 3 here. It was iron filings, which is why it didn't conduct electricity as a solid. So our other metallic thing, zinc, was this last one, zinc. It was mossy zinc, conducted as a solid. Now, this is table sugar, sucrose, which is a polar covalent compound. So that must be up here. Oh, I'm sorry, this is O11, because it's a disaccharide. So that was our polar covalent. It does dissolve in water, but does not conduct electricity. Then we have iodine. Iodine is covalent as well, but it is non-polar. It's perfectly symmetrical. That's why it dissolved in the hexanes. Now we have 2 last compounds. They are both ionic compounds. KCl is a group 1 metal, and a halogen, that's not one of the exceptions. So this one is definitely soluble in water. It follows Shan 1, and it will conduct electricity in water. So KCl will be our ionic compound that is soluble. calcium carbonate, our last but not least, it is an ionic compound, metal, non-metals, but it is not one of those fully soluble salts. It does dissolve a little tiny bit, but not enough that we can see the conductivity in water. So typically this will form a precipitate, and it's one of those insoluble salts, calcium carbonate. I like picking these ones for a couple of reasons, because calcium carbonate in particular, having that insoluble salt, shows that ionic compounds that don't always follow the rules, right? They're not 100% soluble in water. They don't 100% conduct electricity in water. I also like to show iron, especially iron filings, because those little pieces that you would expect them to conduct electricity as a solid, but since they're separate, the atoms are separated, it does not. So there's a lot of good things going on in this lab, but I don't think you'll need really any more than this. And again, you could do melting point if you have a melting point apparatus, but I don't think it's necessary for them to understand the differences in their structure and the properties, their physical properties that result from their structures.